So after the preparation of acids and bases, we'll come to the properties of acids and bases. So first of all, acids, they're sour in taste. They turn blue litmus red, we can say that, phenolphthalein pink, and phenolphthalein, it remains colorless, I'm very sorry, and methyl orange, that is pink. Alright, blue litmus red, phenolphthalein remains colorless, and methyl orange, it turns pink. Alright, that you know it, all of you. Similarly, bases, if you see, bases, they are bitter in taste, already I have said you, they are bitter in taste, and they turn red litmus blue, and phenolphthalein, it turns pink, and methyl orange, it turns yellow, we can say that. Now, the most important property which you are going to study here is that acids and bases, when they react, they undergo neutralization reaction. It's a very important, listen very carefully. It undergoes neutralization reaction. When acids and bases, for example, HCl, when it reacts with NaOH, it give you, that is NaCl and water. So remember that any acid, here you can take any acid, HCl, H2SO4, HNO3, carbonic acid, any acid reacts with any base to form salt and water as the product. So salt is what? Neutral. Water is what? Neutral. So hence the process is known as neutralization. We can say that. Neutralization. So from HCl, what I am going to get? H plus ion. From NaOH, what I am going to get? That is OH minus ion. H plus and OH minus reacts to form what? Water. This is a general reaction of acids and base to form, that is nothing but a neutral solution, that is water. This is called as neutralization. This is known as neutralization. When any acid reacts with any base, the resultant solution is neutral. How do you know? You take here the litmus solution, blue or red litmus, it remains as it is, we can say that. The color does not change. So hence it has been proved that it is neutral in nature. We can say that. This is called as neutralization reaction. The heat which is liberated during the process of neutralization is known as the heat of neutralization. Again I repeat, the heat which is liberated during the process of neutralization is otherwise known as heat of neutralization. That is said to be as heat of neutralization, which is measured in joules or in calories. We can say that because it's an energy. So in this way, when acids react with the base to form salt and water, this is called as neutralization reaction. This is one of the properties, very important property, we can say that. Now next is after that, if you see, when metals reacts with acids, this is the property of acid, is that any metal, for example zinc or magnesium or calcium reacts with acids, for example HCl, it give you what? Zinc chloride and hydrogen gases released. Alright, so magnesium reacts with HCl to form magnesium chloride and hydrogen. Similarly, if I take magnesium with H2SO4, alright, H2SO4, what I am going to get? I am going to get MgSO4 and hydrogen gas is released. So any metals when reacts with acids, alright, what happens is that hydrogen gas is released. Now this reaction also proves that acids are acidic in nature because acids liberate hydrogen gas. This reaction proves. Suppose in the exam will come that prove that it is acidic in nature. How do we come to know? That is, when it reacts with metals, it liberates the hydrogen gas. The production of the hydrogen gas proves that they are acidic in nature because they contains hydrogen, we can say. Similarly, after that, when that is an acid reacts with ammonium salt, for example ammonium chloride, alright, when it is reacting with any of the what you can say acids or bases, for example NaOH, what it is going to produce? It is going to produce nothing but ammonia plus, alright, that is nothing but ammonium chloride. It is going to form nothing but NH4OH and NaCl. Remember that. NH4OH and NaCl. It is a double decomposition reaction. See here, NH4 Cl minus, Na plus OH minus. So NH4 will go with OH to form NH4OH and Na will react with Cl to form NaCl. So you might be thinking, why I am writing ammonia then? Because ammonium hydroxide is unstable. It decomposes to form ammonia and water and NaCl is being produced. So what you find is that this is a strong base. Ammonia is also a base. A strong base that is liberates a weak base or replaces a weak base. So you use a strong base, we get a weak base. We can say that. Clear? So in this way, this is a double decomposition reaction takes place. Remember it. Alright. Now next is, if you see here, that is let us say you are taking some copper chloride. When it reacts with NaOH, copper chloride, what it will give you? Copper hydroxide, COH whole twice, plus NaCl. It's a PPT again, plus NaCl. Alright, you can take here, instead of NaOH, we can take here KOH also. But in the lab, generally, sodium hydroxide and ammonium hydroxide is used as a reagent, preferably. Because potassium hydroxide is not being used because highly corrosive, potassium hydroxide. Even sodium hydroxide is also corrosive, but it's much more than that. So hence, and also it is costly for that particular purpose, sodium hydroxide is preferred. So here copper hydroxide, I got it. Copper hydroxide will give you a blue PPT. Alright, a bluish PPT you will be getting it. Instead of copper chloride, if I take zinc chloride, I will be getting zinc hydroxide. Zinc hydroxide is a gelatinous white PPT you will be getting. Alright, these are the name, remember it, gelatinous white PPT. Suppose if I take here, there is ferrous sulfate, if I take it here. So what I will be getting? I will be getting ferrous hydroxide. Ferrous hydroxide is nothing but a dirty green PPT. Suppose if I take here ferric chloride and NaOH, remember that NaOH has to be there. Then we will be getting ferric hydroxide and NaCl. You will be getting it. Ferric hydroxide is that is nothing but a reddish brown PPT. So all this you will read in details much more in the next chapter, that is analytical chemistry. You will be reading in details about it. I will teach you about it. So these are the basic what you can say properties of acids and bases. We can say that the most important is neutralization. Then acids reacts with this to get this what you can say hydrogen gas. It reacts with what you can say base reacts with an ammonium salt to give you the respective ammonia gas, and in this way we get a PPT. So these are the basic reactions or the properties of acids and bases. Now one more property is that acid when it reacts with the moisture which is present in the air, basically the impurities which are present in the gases, in the atmosphere rather I should say, the impurities are what? Nitrogen dioxide, sulfur dioxide. Carbon dioxide is not an impurity, remember it. So these are the impurities, we can say that, if at all is being present in air. And generally nowadays, of course nowadays it is not there, but previously when the pollution was there highly, so these gases was being present. So what these gases actually does, it reacts with the moisture, it reacts with the water which is present in the air to precipitate in the form of rain or in the form of fog, in the form of mist, in the form of hoar, whatever it is. If it precipitates, and if the pH value of that particular water, means which is precipitating downwards, we can say that, if the pH value is less than 5.6, it is said to be acidic in nature. That particular water is known as acidic in nature, we can say that. And the rain is considered to be as an acid rain. Remember that. There is nitrogen dioxide, sulfur dioxide, or any other gases, we can say that. There is greenhouse gases, this which causes nothing but the greenhouse effect and which causes pollutants, pollution in the air. That's it's considered to be as pollutants, so to say. So these particular gases, because these are the basic, mostly these gases are being present in air. So when it reacts with the moisture which is present in the air, or when it reacts with the water which is present in the air, in the atmosphere, and it precipitates, it comes down in the form of rain or in the form of fog, in the form of mist. Alright, anyway, if it comes on the earth's surface and if its pH is less than 5.6, then it's considered to be as, I'll tell you what is pH. Next we are going to see that pH. What is pH? If the pH value is less than 5.6, it is said to be as an acid rain. And acid rain is highly hazardous for us, acid rain, because acid rain, what it does is that it what you can say percolates in the soil and it decreases the fertility of the soil, we can say that. It also, acid rain is destroying our historical monuments. Basically this particular thing was being observed for the first time when the what you can say the Taj Mahal was losing its dignity, or the Taj Mahal was losing its luster, we can say that. So how it is? Because Taj Mahal is made up of pure marble, that is calcium carbonate. So when sulfuric acid when reacts with calcium carbonate, that is marble, it forms calcium sulfate, which is a pale yellow PPT. So slowly it was being seen that the color or the shine or the what you can say of the marble which is present in Taj Mahal is being losing, it is fading away slowly. Why? Because a pale yellow PPT was what you can say accumulating over the surface of what you can say that is marble, and hence it was losing its luster or the shine or the beauty, whatever you can say that. That is nothing but due to acid rain. So acid rain is quite hazardous to us. Now we'll understand that how it is being formed. Now let's say there is nitrogen, you know, it is being present in the air. It combines with oxygen under lightning discharge or under high temperature, we can say, to form nitric oxide, NO. Nitric oxide further combines with oxygen in the air to form nitrogen dioxide, NO2 gas. Now NO2 gas, when it reacts with water, it forms nitrous acid and nitric acid. HNO2 and HNO3, nitrous acid and nitric acid is being produced. You can balance this equation later on, we can say that. So basically, again I repeat, nitrogen when reacts with oxygen under lightning discharge, because remember that nitrogen is an inert, nitrogen is basically inert in nature. Why? I don't say it's an inert gas, I say it is inert in nature. Why? Because nitrogen contains 3 bonds, triple bond. If you have studied in chemical bonding, N triple bond N. Alright, so for that reason it is inert in nature, because it is very difficult to break these 3 bonds under ordinary conditions. So under what you can say highly rigorous condition, that is under lightning discharge, when the temperature is around 3500 to 4000 degrees Celsius or more than that also, it forms nitric oxide, you can say that. Nitric oxide reacts with oxygen which is in the air itself to form nitrogen dioxide, which is a reddish brown colored gas, and this is a colorless gas. This reacts with the moisture which is present in the air, or when it precipitates in the form of rain. So it forms nitrous acid and nitric acid. This nitric acid and nitrous acid, it percolates in the soil. That is in the soil, what you can say the minerals are there. It reacts and it forms what you can say the PPT, and those particular substances the soil, the plants will not absorb, and hence it decreases the fertility of the soil, we can say that. Clear? So this is otherwise known as the acid rain, because you can see the acids is coming with the rain droplets. Similarly, sulfur dioxide reacts to form sulfuric acid. Alright, in this way. So this is acid rain, we can say that. Clear? So this is about your acid rain. Thank you very much.